Hi and welcome to the lesson where we'll see an approach to process data at rest in a streaming manner. And this approach is called change data capture. So the key highlight is that you can process data at rest, so data written, for example, to a relational database, or maybe some NoSQL stores that support this CDC pattern. You can process it in streaming. So each time a write is made on the database, you can directly capture it and process in your real stream applications. So it works similarly to database triggers you might have been written in the past. So generally the idea is to define some callback on database events like insert, update, or delete, and whenever one of these events happens, you will call a SQL functions. Here the idea is the same because it also has a concept of callback, except that the implementation is different because it will not be a SQL function, but a function that writes this specific change to some streaming broker for streaming processing afterwards. To give you a picture how CDC relates to other data processing modes, let's see how to get data from a data at rest old way. So we follow this CDC pattern. So in this approach, we have a batch pipeline that is scheduled every X or Y, X hours or Y minutes. We get last changes from the previous load with the incremental load pattern, and later we write them to the streaming broker. However, this approach has several drawbacks that are very serious for real-time and streaming processing. So first, the schedule reduces the data freshness. You can see, even if you have a schedule for 10 minutes, 5 minutes, the data will be still less fresh than for data copied and migrated in real time. Otherwise, there is also get last changes aspect. As I said in the lesson in the module 2 about batch data ingestion, sometimes you may miss some information. So for example, if the deletes are implemented as in-place operations, so the SQL delete from instead of update a delete marker flag in the table, you will simply miss them because it will not detect this change by simply taking the new rows appeared between the runs. And finally, in the write to the streaming brokers, you highly increase the write throughput because you write a lot of data at once. It's the flow in your, for example, in your monitoring layer, you should see the flow like that for all these scheduled synchronizations. In the new way, so with the change data capture, we rely on something which is called commit log. So as you said already, it's a kind of persistence layer for all the changes made in the database. And the idea is to have a watcher application that will analyze this commit log in real time and deliver the data to the streaming broker continuously. So you will not have the peaks, you will have good data freshness, and generally the streaming applications will operate on more real-time data. And additionally, you can also handle the delays because they are also written in the commit log. And in this pattern, very often you will not read the main database because it's not only read intensive because you have the select statements on it, but also write intensive because you have all the applications reading the transactional data. So here we will very often use a read replica, so create a replica, a live replica for the master node and read the data in CDC manner directly from there. And if you are thinking that it's only for relational databases, you are wrong because there are some NoSQL stores, of course, like Apache Cassandra, ScyllaDB, or MongoDB with the CDC capability. And you can also implement it with files, namely with Delta Lake table file format. And when to use it, so what to do with all this CDC, we can have a heterogeneous database replication. So we can have the CDC daemon reading the data, pushing it to streaming broker, and later we can have a streaming job that will reformat this data and adapt it to another database format. We can also have some kind of notification system, so you can detect any serious events like new order, first order of the customer, and other interesting things. You can also do some in-flight analytics, even though you have data stored on SQL and it should be enough to do ad hoc analysis, but still you can do some in-flight analysis to implement streaming use cases. For example, the fraud detection, which is very often reserved to streaming world because you don't want to detect the fraud after the fact, but before. So in the category of heterogeneous database replication, you can use this CDC to create an analytical store from the transactional store. So copy the data to some analytical database, like for example, data warehouse. And finally, you can have some event-driven architecture. You can imagine having a distributed cache somewhere and use the information from the transactional database to, for example, invalidate or update the distributed cache. And that's all for this lesson. CDC is not the single way to process data addressed in streaming way, and I hope you will see it with me in the next lesson. Thanks for watching.